All right, so now we're going to talk about planes. And why are we doing that? A plane, we have multiple planes on this part. A lot of these terms and even these planes right here, this came from a drafting test that someone asked Doug Smith, since he's been doing this for years and teaching it, asked them to take this test to see if he thought it was a good test to give to someone that were taking a drafting certification or a drafting exam. That's where these terms came from. That's where these planes came from, the vertex, the different kinds of planes. And that's why we're trying to teach this, is because people out in the field somewhere are actually testing with these terms. So we thought it'd be good to teach you guys. So if this were our primary view, this would be our top and our right view. And not always do we draw 6 views. If I can put all the size and location notations in one view, I only need one view. So it comes down to that, you guys. It comes down to clarity. And if you were given a certain amount of money to make a drawing, would you want to draw 6 views of that part? And it's a flat rate. You weren't paid hourly. Would you draw it in 6 views? Or would you draw it in the minimum number of views to be finished? You make more money per hour drawing in the minimum number of views. So we're going to talk about that as we go. How many views will we really need of this to completely describe it? So we have these views right here that we could project. We're looking at planes right here. We're looking at planes in the front plane. We're looking at planes in the top plane. We're looking at planes in the right view. And then if I actually took a piece of paper and I traced over that, trying to visualize what that is, this is what it would look like. We wouldn't see these angled sides. We wouldn't see these angled corners. They flatten out. So do you see this length of this line right here? The length of this line right here is, it is truncated or not as long when you look at it from the front because it's leaning back. It's got depth to it. So not always can we dimension something in this view. I might have to dimension this in another way because I'll never get its true size. Because all I'm doing is looking at the front and projecting that point up here, and it doesn't really get me the depth going back in 3D. It's just vertical, like that to that. And that's certainly not the same distance all the way down that line. So that's why we have to have different views. We cannot measure angles in this front view. I can't tell you how long that line is or whatever. It's foreshortened. But in the top view, I can certainly put an angle there and there, or the length of that line, or put X and Y dimensions. So it takes as many views as necessary to describe the correct size and location of each feature. Now, I'm going to tell you what a feature is. Everybody heads up. A feature is something you can touch. I can touch this plane. A plane is a feature. A hole is a feature. This plane or this notch, these surfaces are features. Features are described as something that you can touch. All right, so every feature, every place I can touch, I need to dimension it to its true size when I'm looking at it in the correct view to get that size. So let's look at these weird views for angled sides. I can't get that anywhere, but I can get it from the top view. What about that one? How am I going to do that corner? That is a corner that's rotated. So let's go to the next one. This is not working. My page down isn't working. Okay, so here's the top view projected. Once again, this is truncated. I could get my angles from that one. So I could get the height in the front view. I could get the location and the size of the hole because I can touch it in this front view. I can get the width of this notch, but I can't get the depth. I've got to have this top view to get the depth. I have to have the top view to get these angles. I have to get the top view, have the top view for the depth of this protrusion right here, and also the overall depth. I can't get that from the front. Now I could get it from the side view, but I've got to have this view for this notch. I can't get that here. It's hidden. Can't dimension that. So then I need that top view, right? I need that for that notch and these angles at a very minimum. And then do I need the side view? What can I get from the side view? Well, I can get the depth again. I could get the height of this. I could get the height of that from the front view though, right? I can touch the top and the bottom. I can dimension that there. I can get the depths here, which is this and this. And essentially, if you took this part and you rotated it around, that's like the corner. If you turned it around this corner, you'd be looking at the same kind of depths of the part in the top or here. I still can't get this. I still can't get this corner right here, and I can't dimension these angles right here. So really, to me, this right side view doesn't do anything for me. If I can dimension the width, this thickness, I can get the height here. I can dimension this, how far this is, and how far this cut is right here. I can get all that right there. So I don't even need this right view. So that tells me I could get away with 2 views on that one. Is there anything that I can't dimension? Well, there's certainly something here. This is called an inclined plane. It is an angled plane that is not rotated. Think about the top of a pitch of a house. That is also called an inclined plane. It has a hinge point and it all rotates in the same direction. An oblique surface, however, could be an angled surface that's also rotated. So an oblique surface is inclined and rotated relative to one of these sides. So if this were not rotated, this could be the same angle all the way across, but it kind of angles out and kind of stops right here. So how do we get this view? We might have to have something called an auxiliary view, and I don't know where it comes in this chapter, but we would actually take a view straight from this surface and project it out to show the true size of this oblique surface. So we would have to have another view of this part other than the primary and the top. So that's kind of how we do that. That's kind of how we think about how many views that we need. So let's look at this one. What we want to do is we want to describe how many views are necessary. Let me teach you, this is a trick. So any side of the part that has a hole in it, you have to have that view, because you have to be able to touch that hole to locate it and say its size. So I could either use the front or I could use the back side of that part. I gotta have one of those views. I need to see the height. I could do that in this primary view, or what they're calling the front. You see this arrow right here? It's calling this the front view. It's calling this a side view and this a top view. So I have to have the top or the right side to get my depth. That's where we show the depth. We can get the height and the height of this cut or the step in the front view. I can get my angles in the front view. I can get the location and the width of this notch and the depth in the front view. I have to have the depth of this cut. I cannot see that in the front view. This all looks like it's on the same plane from the front view. I cannot see this depth. I can't see it in the right side view because it would be hidden, and I cannot, touching through this side, I cannot touch this cut. So in this one, if I use this as this front view as my primary, because it has angles and holes, that's a pretty good shape, right? Then I might use the top view to get this depth. And I could get all dimensions in the front view and the top view, not needing this side view, because I can get how deep it goes back and forth without the side view. I can get the height in the front view. So just knowing when things have angles and holes, you're going to have to show that view no matter what it is. And it may be your job to just pick a view as your primary, but if your primary view makes you have a bunch more views to completely put all the size and location notations, then you've wasted a lot more of the company's time. Here's the deal. If you're working hourly and you're making 6 views instead of 3 views for a part, you're costing your company money. You're not being efficient. So you want to start first by visualizing that part and thinking about all the features in it. If there are cuts, you have to show the view where you can touch the cut. I can touch the depth of this cut from the top. I can touch this width from the top. I can touch the depth from the front. I can touch this hole from the front or the location from the front. Cannot touch those cuts from this right side view. So to me, it would be better. And if I wanted to put 3 views, it's fine. I'm not going to have any view. I'll tell you this, I will not draw any view and not have a size or location notation in it. If it's all too cluttered and in just one view, I'm going to spread those around to other views. But just remember, you cannot dimension things that you can't touch. All right. So no hidden line dimensions. All right. Or size notations. Okay. So if we wanted to project this, this is what it looked like. This all looks like it's a plane. I can't tell if this is protruding or if this is solid and coming out toward me like a pin. Can't tell depths on this one, but I can get a pretty good profile. I can get my height. I can get the height of this, whatever this is. I can't tell if this is stepping out further than this or this is stepping out further, but they definitely have an edge where we change. And we'll always have an edge where an incline goes to a planar face or a straight face. So we have that one. We'll go through this one. From the top, I can touch these. And you see where this hidden lines, this starts to get really confusing, right? So the visible lines, I know I can touch. Hidden lines, I can't. This is that hole that goes through, and I know it's a hole because this axial center line goes all the way through, and it goes beyond the circular element, so it goes outside. Hidden lines will never stop at geometry. Edges stop at geometry. Center lines go beyond geometry every time to let you know that that's not geometry. You know, these breaks could be so small that they kind of look like hidden lines, but it doesn't stop at the edge of the material. It goes on. That shows me that's a center line. Edges stop at the edge of geometry where there's material stop. So this is the hole, one side and the other, the full diameter, and this is the center axis. It goes all the way through. All right, so we can't dimension these things here, but we can dimension the depth of this, and we have to have that. So we could locate where this starts and how wide it is in the front if we want to, or we could also locate it here and how wide it is and how deep it is. And what I like to do is group all the location and size notations in one view if possible. And I'm going to exaggerate that later, and you're going to see why that might be best. So in the right side view, I can't put an angle here, and I can't give the length of that line is not correct in this projection. All I can do is say how high it is, how wide this part is, how high this step is, and how deep it goes back. That's all I can get in this one. So, if I'm really trying to pare down to how many views I need, I probably don't need this view. So if we started sketching this, you guys, we might sketch all the visible lines first. Now, I'm going to show you this trick on the miter line. This is really important. We just have 5 more minutes. So here is the front view. Now I know that I'm going to line my right side view up over here. If I'm going to draw 3 views, and at first we're going to draw all 3 views, and we could have 6, but the customary views that we draw over and over and over are primary, top, and the right side view. Now it could be switched around depending on the part, but we're going to draw those over and over and over to get used to projecting geometry between one view to the next. So this is why it's so important. So this is what I do when I draw something. I'm going to draw a box first. And then in the corner, if I'm drawing the top view and the right side view down here, in the corner of that box, I'm going to draw the end point of that wants to be in that corner, and this is 45 degrees from horizontal or from vertical, whichever one is 45 degrees. Has to be perfect 45 degrees or you'll be off. So if you draw the first one, you have to measure that one and draw it. But then I know the bottoms are the same. So I'm going to start this one in this corner, and I'm going to get the depth, and then I can project the height from here straight across because they're in alignment horizontally. Then I have to measure how deep this goes back, and then the height of the same part is going to be the same in both views, so I draw that straight across. Then I have this right here. I have this inclined plane. Now that is absolutely on the same plane as the bottom of this notch. So I'm going to put King Daddy, the visible line over here for that inclined plane, and no hidden line. You don't step that down. It needs to be absolutely horizontally in alignment with this. So you just draw one line. Visible line overrides hidden line overrides center lines. Visible lines override everything. So I'm going to put that for this corner right here. And a cool way to do this is to take a ruler and put it down here. And then I come up. Oh, I've got a hole right here. Well, I can project from the southern quadrant or the very bottom apex of this straight over. That's where my hidden line starts for my hole. And then the top extent of that hole. And then from this center mark, if you have a bullseye, you got to have an axial center line. Now, why doesn't that come all the way out beyond the material here? Because the hole starts back here at the back of this notch. So you just come beyond the circular object, not beyond the square object, but the hole starts right here. And so you just go outside a little bit. We've got a line, one dash, and then another line. You don't have to have multiple dashes, you guys. It's going to start looking like a hidden line, which is uniform dashes like this. Can you guys see that? I don't know. I think I have my cursor on the wrong side. So this is a hidden line. That's a hidden hole. Here's a hidden vertical edge. That is the back of this. Now at the top, the cool thing about the miter line is this view is just rotated 90 degrees and set up here. It's turned around this corner right here. This is called a miter line. Nobody taught me this. I had to redraw and redraw and redraw. So the width of this depth right here, if you go up, cross the miter line, wherever that crosses, you go across, that will be equidistant here as it is over here. So I can also do that with this. Go up to the left. So if I start my part in that corner, and this miter line is also at that same height and comes down 45 degrees, then I guarantee you that this depth, if you go up to that 45 and go across, that's going to be the same depth from the top to the bottom of this view. Now I can project this edge up for this notch, And then I can measure this. And so usually I'm going to draw my visible lines first in all my views. And what that does is it gives me these visible lines to project over where the hidden lines are going to be. Same thing here with this cut right here. I can project from here down and get this hidden line right here to show where that notch stops. From this hole, I'm going to project from the east and west quadrants and go up here. This hole starts and stops at the back of the part and the front of this notch. And then this axial center line goes beyond only the circular object. But hidden lines are cut edges, you guys. Hidden lines are always cut edges, so they always stop at the material. So it's real easy, sorry about that, it's real easy to understand that this is a center line and this is a hidden line because it stops at geometry. So does that make any sense to you guys? You would have to measure out, your visible lines in this view. And then I've got to measure my depth either in this view or in this view, because then I can project over and down, or I can project up and over and create my depths from that. So you do all this with really light lines. You see all these lines drawn on here? They want to be so light that if you took it to a copy machine, it would not show up. I mean, super, super light. Yes, question.
What do you use to make those lines?
I use a pencil. I use the same pencil that I use a mechanical pencil.
I mean, in AutoCAD. Are we not talking about AutoCAD right now? Like doing this in AutoCAD?
We're going to start sketching manually first. Okay, now, in AutoCAD, you could actually use construction lines, or you can just hover over this and drag it out in Object, Snap, Track, and click to start and click to finish. You don't have to draw lines like this.
But you would do the same thing if you're going to turn in like some work for a customer. You'd make a box first and then...
Yeah, and you want to make all those super light, you guys. The box, the miter line, and these projected lines, you want to make so light that you don't have to clean them up later. If you take this to a Xerox machine or a copier, and you make a copy of it, and you can see those lines, that's usually what I do with my students when we're in person. I'll take those drawings, and if I can see, I give them back to them after I've scanned them in. If you can see those lines, you need to go and erase those back. All you want are the visible, hidden, and center lines showing, and all the rest of this, you want to be very light. Now, I could use a ruler and set it right here and not make this line. I could just start it right here and go across. But that ruler needs to be parallel to this line. So that's why, a drafting table or a T-square or something always helps. But we're going to be drawing on a grid, you guys, so it's going to be super easy. You're not going to have to worry about, horizontal, vertical lines being off and like that. So let's go down to what we're going to talk about next. And I know we're out of time. So here are the standards for thickness. Notice that your hidden line and your center lines are half as heavy. So after you get finished drawing something like this, you clean it up, and it says darken the lines to define the views. So you go back and you make these darker so that it will reproduce. So when I'm drawing the actual visible lines, I'm drawing those heavy. And if you draw them heavy and you make a mistake, you have to erase it. It's hard to get it to erase if you're doing this with pencil, okay? So we have thicknesses for visible lines. I don't know why this is doing this to me. Come on. See, my mouse is messed up. My mouse is sitting out on my fence post, just delivered by Amazon. Okay, so we make center marks, center lines, hidden lines, half the thickness or half the weight, half the darkness. And visible lines will be thicker and darker. Okay, So in a formal drawing, we might have something like this. And we can put quantities on these instead of dimensioning them over and over. And we'll talk about that. So what I want you guys to do is I want you to look at the rest of this. And I'm going to tell you what page we're on here. And I want you to watch the videos and the direction, because what you need to be doing over the weekend is drawing some sketches of these objects. Now, what I might do is make a video showing you how to do it, talking to you about the pages. I want you guys to start sketching on some grid, and I'm going to show you what it's like. This is it. Okay? In your book, it's exercise 2-1. It has the first 3 views drawn for you. Do you notice that every one of these has a miter line on it? So looking at these, you're going to count. There are no dimensions on this yet. We haven't even talked about that. You're going to count on these. This is 10, up 2, over 1, up 1, back 3, up 3, over 4, down 2, back to a vertical line. This is my primary view because it has an arrow. I want the top view looking down, and I want the right side view. So we might, I think I'm going to have to toss you guys another direction video and do some of these and explain that when you cannot see the back of these holes, they go all the way through. Every time you see a circular object that is not protruding and you can't see the back of it, assume it goes all the way through. This cut right here goes all the way through. So I'm going to make a video describing the first 2 sheets, and you're going to have 3 views of all 9 parts. When you come back, we're going to go through those, through the answers for that. The answers are also in Blackboard. There are some videos for 3D models to help you envision it. But I'm just going to draw it in paint on my screen, make some videos of that to help you guys understand how I would do it myself. And I'm going to give you some exercises to watch videos, to look at it in the book, and to do some drawings. Now, if you have any questions on any of this, you guys can get in touch with me and we can go over it together. But I want you to try doing some of this. There are videos explaining this, and I hate to just toss you guys out there. I really hate it. But I was going to show you this. So do you see that there is a primary view? The arrow points to the primary view, so always look at this, and it does change on other sheets. So this is what it would look like in the primary view. That is a hidden line right there. It's hard to see because this is so tiny, because I cannot touch that cut right there. From the top, I have a hidden line right here because there is an underside edge right there, that corner right here. And there is a back edge back here that shows a hidden edge right here. So what I usually do, and I had a piece of paper. Let me see if I have it. I'm just going to show you guys something real quick. This is in paint. Oh, I had it in paint. Let me do it. Okay. So if I were going to draw something here, I would draw it. I would start, you see that you're going to have corners. So if you have a bounding box, these are going to be the edges of all 3 of your views. And then I would start with my first view, and I'd count over 10. And I go up 1, over 1, up 1, back 2, up 4, or up 3, over 4, down 2, and back. And this is an approximate, right? And then I would draw the side view, and maybe it's 5 deep. So it's going to be just as high. And then I'm going to have this step right here. So I'm going to have an edge right here. And I've got an edge right here that I can touch from the right side. Whatever you can touch from the right side, you're going to draw that. and you got to count the number of squares for its depth. So the depth on this is going to be the same as the depth in the top view. So there's my, using my miter line, here's how wide this part is. So I'm halfway there. Now I have this step right here. What edges can I touch from the top? I can touch this one, touch this one. These two are right in line, so I'm just going to draw that one. I can touch this one. And then it goes all the way to the back. So over here, I had a little notch. I need to draw that in. And so this notch, I can project that up and over. And that starts right here and goes across. And it's 1 unit back here. Now you can count the units and draw it, or you can use your miter line. So now I've got a hidden line right here. So I'm going to draw a little dash line. That's this edge right here. I can't touch that here. What else? I've got this plane right here. So this is when I use a ruler. I've got this edge. I've got that edge. I've got that edge. Oh, there's a corner right there. I'm going to go across and I'm going to make a hidden line over here for that back plane because it's not on the same height as this one. Up here, I'm going to go from the right. Okay, I've got that edge. Oh, I don't have this corner right here. So I've got to have a hidden line down here for that little notch underneath that plane. Then I'll come over and yes, I've got these corners, go over to that, and then I'm done. So in the end, and I know, see, I would erase some of these things out, but in the end, it's going to look something like this. And if I zoomed in on this, you would see that these are hidden lines right here, hidden line. And let me show you that. There it is right there. So you're simply going to count the number of squares, draw that. And if you want to draw that box up to your miter line is in all your sheets. Where do you get your sheets? Your sheets are in the back of your book. They're also in the exercises. So I'm going to keep going with this until you guys make me stop. But here are the videos on multiple view drawings. And if you go down here, here's exercises 2.1 and 2.2. And if I click on this, here is your grid sheet that you can download. And you draw this with pencil. You will not be handing this in. But I want to show you something. The first one's already done. So if you click on this, it'll open it up. You can download it. You can print it. Or you can tear these out of the back of your book. All right. I might send you just this grid so that you can use this. Question?
What if you just have some regular...
Yeah, like engineering square stuff.
Could you just use this?
You can do that, but you need to make sure that you have enough squares in your miter line. This is way better. Believe me.
You could just draw your own miter line though, right?
You could still draw the miter line. You got to make sure you have a 45-degree angle. You've got to draw a box that's big enough for both of your views to have some space in between. Okay. So you could use this as an example and draw that, and every one of these are the same, you guys. So every one of your grid sheets, and I might just send you just a blank grid sheet PDF. If you want to print it, it's fine. If you want to use something else, it's fine. This is for you. I'm not going to be taking a grade on this. Okay, so you're going to have 3 views of every part. That's 27 views on one sheet. All right. So watch this video on exercise 2.1, sketch 2. It shows you the second sketch. And this is really cool. It shows you the 3D models.
Videos like this
before,
no. But here's the big secret. Anyone can make one of these videos in a...
Okay. So
this
starts through those.
Top and the right side views of the objects in exercise 2.1.
All right. So let me stop this. You can watch this and it's going to explain it a lot more. He's actually drawing some of this for you. But here it has the 3D models of those views.
Video is to help you visualize the front, top, and the right side views.
Let me see
of
if I
the
can turn this
objects
off.
and exercise.
So let's move this on forward. So it's showing you this part. And it's to help you visualize this. So he's going to turn this to the front view. There's your front view, the top view, and back to the front. And then you turn it to the right view. So there are some videos to help you guys visualize what these look like so that you can draw these in these grids. All right, let me get back to, so that's this right here. You guys really want to watch these videos. Multi-view sketching exercise 2, the 3D models talks about that. And then don't go look at here are all the solutions. Don't go look at the solutions before you draw it. Go try and draw it first, and then go look at the solutions. Okay, and then you can make any kind of changes. Write down questions that you have when you look at the solutions. Then we have another sheet. And here is your video on that and your grid sheet that you can download that has nothing drawn. Okay, that's just a grid sheet. So you need to, let me see, where are all the models? There it is, multi-view drawing PDF chapter 2. So if you go into this one, if you don't have your book, you will see exercise 2.1, 2.2. And that has 9 parts in each sheet. And we want all 3 views. So I'm going to make a little video showing you how I'd make these in Paint. And if you have any questions, just reach out to me. And we're going to have to depend. This is where my class gets behind because I want to take so much time on this. I don't want to leave you guys not feeling good about this. And I really hate how we had to rush through this. But I'm trying to stay in alignment with the other classes, and they're already moving forward. So what I'm going to do is I'm going to give you this assignment. We're going to come back after the weekend. We're going to come back on Monday, and we're going to talk about these drawings, and we're going to see if there are any questions, and then we may go over the next sheet. So do both complete sheets if you can. It shows the, right here, it shows the answers to both sheets for you. So there's 3D model videos. Here are the solutions to the first sheet. So you're going to go and check your work. Reach out to me if you don't understand something about the way you drew it as opposed to this. We can get together on a meeting. You can show me on the camera your drawing, or you can take a picture of it and upload it and I can see it. And we can go through that, okay? But I want you guys to go through this exercise. It's exercise 2.1 and 2.2. This is your first assignment. It's not for a grade. This is for completion, okay? But you got to do these. And it may be simplistic to you, but you might learn something in it. So here are the solutions for exercise 2.2. You're going to use this PDF right here. And I keep trying to get it to upload, and it's finally done for the entire chapter 2. But if you go down to, and let's see where it is, we kind of talked through all this stuff. It was a lot to go through. We haven't even gone through scales. There they are. So here's exercise 2.1. And exercise 2.2. So you see your primary view is with this arrow. So if you wanted to print this page, you can print to a PDF, and then you can print that. And you can just say current page, or I might have to specify what page. I kind of hate that. Or you can take a snippet and then print that. So some of these may be 1.5. You see that they're kind of they're off the grid. Some of these may be at a half grid, like this back point. But you can see the back of this is 1 unit deep. That doesn't go all the way through. So I'll make a little video on what goes all the way through, what doesn't, and I'll just draw some of this stuff for you guys in a better way than what I did earlier, okay? All right, thank you guys. I'm going to send you an announcement for that. You've got all weekend to do it, but just like with anything else, jump on it early. You don't know how long it's going to take you, and you want to get finished with this. And
So I
then
have a
enjoy
question.
your weekend. Yes.
So where did you go to find that right now? Chapter 2, whatever that you were showing right now.
Yeah, so if you go down in Blackboard, let me
Uh-huh.
show my screen to chapter 2.
Okay.
Let me share this. Go down to chapter 2.
Oh.
Let me get there. And here's the reading assignment. It goes down here to exercise 2.1 and 2.2.
All right.
All that was that page that I was showing you.
Yeah, because right now I'm still waiting for my textbooks from Amazon, and it
That's
says
okay. Here's the
yeah,
entire
it's
PDF of chapter 2. The entire PDF of chapter 2. The entire, bye-bye. The entire PDF of the first 4 chapters is given to you in each chapter.
okay. All right, man.
Okay,
Yeah,
so that'll give you some time.
all right, man. That was my question. All right, man.
Yeah. I'll send you an email with all the links and what, that kind of thing. I'll send
All
you
right.
your homework in an email.
Will do, man. Thank you.
All right. Thank you, guys.
Oh, I do have a question though. You said it wasn't for a grade, but it's a completion.
Right.
So do we still turn it in or scan it? and
No,
send it
you
to
don't turn it in. We're going to go over it together. So what
Okay.
we're going to try and do is have the first 2 sheets done when we get back on Monday so that we can discuss it and see if anybody has any questions.
Okay, very good.
Okay?
Okay, thank
Thank
you.
you.
Bye. Thank you.
Bye-bye. Have a good one.
Hello?
Hello, Uriel.
Oh, yes, ma'am. I can hear you very clearly. Yeah, so I forgot to ask you a question right before I was about to get off. But for the grid sheet, can we find them on the for the chapter 2 multi-view drawing PDF? Because I don't have my
Yes,
book. I'm
it's
still
under
waiting.
chapter 2. It's a PDF for you to download and print.
Uh-huh. Okay, and can we find those grid sheets at the very end when the
They're
the
in the
very
back of
end?
the book, or they're under chapter 2 to print, and it says grid sheet for you to print.
Oh, okay, yeah, yeah, the step 2 exercise, right?
Yeah. Yes.
Okay, just print them
Yeah.
out. Okay, cool.
Yeah,
Yeah, because
there's
I'm not.
step.
Yeah,
Uh-huh.
because I'm still waiting for my textbook from Amazon. They said that
Okay.
it should be delivered February 3rd. It could be
That's
before
okay. The
then.
first 4 chapters are given to you, okay?
All right, man. Oh, and so for the textbook, we could find those grid sheets. They're in there, right? Your physical
Yeah, they're in the
textbook.
very back of the book.
Okay.
Uh-huh.
Okay. All right, man. All right. Yeah, that was my question. I just forgot to ask you that question right before I was gonna. Um,
Okay.
all right, man. All right. Well, you have a great. I guess next Monday. Yeah, next Monday. We'll see you.
Yeah.
All right, man.
We'll see you on Monday.
Yes, man. Have a great weekend. Bye bye.
All right, you too.